Okay, we've been asked to find the gradient function of a quadratic using the definition of a derivative. Now, for those of you who don't know, the definition of a derivative for a function of x, i.e. f prime of x, they say is equal to the limit as h approaches 0 of the function at x plus h minus the function at x divided by h. Cool. So basically what this does is it's what's called the limiting chord process. So what you're doing is you're getting two y points and you're taking them over a particular x value or h, and you make h approach 0. So what happens is the average rate of change approaches an instantaneous rate of change. Okay, so let's go about solving this. I'll just change the color or just make a line. Okay, so to solve this using the definition of a derivative, what we're going to do is we're first of all going to, so the derivative of this function is going to be equal to the limit as h approaches 0. Now I'm going to put it in brackets, just makes it easier to see. So the function at x plus h is going to be, what we do is we just get the function and we replace the x's with x plus h. So we have 2 bracket x plus h squared plus 5 bracket x plus h minus 7. Now this is quite a tedious process, but if you do any kind of introductory calculus class, you're probably going to get a question like this in an exam, so it's worth knowing. So we have to minus then the function at x, which I'll just put this in brackets as well, which is just 2x squared plus 5x minus 7. And this, remember, is all divided by h. Cool. So basically from here, once you've subbed everything in, it turns into more of an algebra exercise than anything else. So hopefully you guys will know that the expansion of x plus h all squared is equal to x squared plus 2xh plus h squared. It is not equal to x squared plus h squared. So this is what that initial expansion is. So what we're going to have is we're going to just use that little piece of information there, and we're going to get the limit as h approaches 0 of. So we're going to have 2 times that. So what do we have? We have 2x squared plus 4xh plus 2h squared. Then we're going to multiply the second set of brackets plus 5x plus 5h minus 7. And then we're going to just multiply that negative into that second bracket. So it's negative 2x squared minus 5x plus 7. Cool. And all of that is over h. Now, when you're doing any of these, especially when they're quadratics, they're always the same process. What we're going to do now is hopefully you'll be able to see we can do a bit of cancelling out of terms. We have 2x squared here and a negative 2x squared there, so we can just cancel those two out. We have a 5x here and a negative 5x there. We can cancel those two out. We have a minus 7 plus 7, so they cancel out to 0. And so we are left with, after that, the limit as h approaches 0, God, my limit bit's getting messier every time, of 4xh plus 2h squared plus 5h, all divided by h. Great, well that's getting a lot smaller, so that's nice to see. So the next step that you will always have to do is you're going to factorize, because if we're going to take h equal to 0, this denominator here will tend to 0, and then we will have an undefined fraction there. So what we have to do is we have to try and cancel out or get rid of the denominator. So the way we do that is we're going to factorize the numerator. So we have the limit as h approaches 0 of, now we're going to factorize the numerator by h. And then we're going to put that over the denominator. Now it's pretty easy to see that these two can cancel each other out. And finally, we're left with the limit as h approaches 0 of 4x plus 2h plus 5. Now what we then do is we take the limit, so we take h to 0, and what happens is this 2h here, this will tend to 0, and h going to 0 doesn't affect the plus 5 or the 4x. So because that goes to 0, we can then say, well, therefore, f prime of x, or our gradient function, is what the question's asking, is equal to 4x plus 5. So that was solving or getting a gradient function using the definition of a derivative, or the limiting chord process. I hope this example helps you in any questions that you have.